automatic temperature control DC fan. With the advancement in technology, intelligent systems are introduced every day. Everything is getting more sophisticated and intelligible. There is an increase in the demand of cutting-edge technology and smart electronic systems. This project aims to give an overview of a standalone automatic fan speed controller that controls the speed of a DC fan according to the room temperature. This is a closed-loop feedback control system. We can control the speed of a DC motor by simply controlling its input voltage, and the most common method of doing that is by using PWM technique. LCD display is displaying the room temperature in degrees Celsius and fan speed in percentage. DHT11 sensor is used to measure the room temperature. Here is the connection diagram of this project. 16x2 LCD display has 2 lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5-volt. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. DHT11 sensor has 3 pins: 5-volt, ground, and output. 5-volt pin of sensor is connected with the 5-volt pin of Arduino. Ground pin of sensor is connected with the ground pin of Arduino. Output pin is connected with the 0 pin of Arduino. NPN transistor BC547 is used to on and off the DC motor. Transistor has 3 pins: base, emitter, and collector. Base terminal is connected with pin number 9 of Arduino. Emitter is connected with the ground. Collector terminal can be connected with any one terminal of DC motor. Second terminal of the motor is connected with the V-in pin of Arduino. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line #include liquid crystal.h. Now we will declare the name of the used pins in the sequence of RS, enable, D4, D5, D6, and D7. We have connected RS pin of LCD with pin number 12 of Arduino, D7 of LCD with pin number 2 of Arduino. Now we will include the library of DHT11 sensor. To include the library, we will write #include DHT.h. Output pin of the sensor is connected with pin A0 of Arduino. Fan is connected at pin number 9 of Arduino. Fan speed and fan LCD are 2 integer type variables. We will give high or low signals to the transistor connected at pin number 9. So we will make pin number 9 an output pin. Void loop. This function will run over and over again. So whatever we write inside, it will repeat forever. DHT.read11 DHT a pin. It will receive the data from the sensor connected at pin A0 of Arduino. LCD print DHT.temperature. It will print the reading of temperature on the LCD display. Fan speed equal map DHT.temperature 25, 50, 20, 255. This function will regulate the fan speed from low to high between the temperature 25 to 50 degree. It will give lowest speed at temperature 25 degree, and it will give maximum speed at temperature 50 degree. It will map the PWM signal with the temperature. Analog write fan speed. This function will give PWM pulses to the transistor BC547. Fan LCD equal map DHT.temperature 25, 50, 0, 100. This function will measure the fan speed in percentage. LCD set cursor 0,1. It will print the message in the next line on the LCD display. LCD.print_fan LCD. This function will print the fan speed in percentage on the LCD screen. Delay 1000. This function will generate a 1 second of delay. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1 and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4 and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Now we will connect the LCD display with our Arduino hardware board. Connect the red wire with 5 volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect a red wire at VCC pin, black wire at ground pin, and a yellow wire at output pin of the sensor. Now connect the red wire with 5 volt pin of Arduino, black wire at ground pin, and yellow wire at A0 pin of Arduino. Now we will take a NPN transistor BC547. We will connect a 220 ohm resistor at its base terminal. Now we will connect a green wire with the second end of resistor. Now connect a black wire at its emitter terminal. Now we will connect one end of DC motor with the collector end of transistor. Now connect a red wire with the second end of DC motor. Now connect the red wire of the motor with the V-in pin, black wire of transistor with the ground pin, and green wire of the transistor with pin number 9 of Arduino. Now we will power up our project and test its functionality. We will now use a matchstick to increase the surrounding temperature of the sensor. We can see that the temperature reading is changing on the screen. We can see that the fan speed is changing with the temperature. Our project is working perfectly. I hope you enjoyed the video and learned something from it. For any help in your project, or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.